Pair programming is an essential part of the computer science curriculum, and the lack of pair programming and hybrid synchronous learning heavily affects students, both those in person and those online. There are very few options available to combat this issue and meet the needs of the 7 stages of action that students will typically take in order to collaborate on an assignment. As well as this, many of these solutions are complex to use and they don't have the ease of setup that is necessary for in-class activities.
The intent of pair programming is to have one student be the driver that writes the code while the other overlooks the process and checks for mistakes. It teaches students how to delegate work, create cleaner and more efficient code, and problem solve as a unit. Unfortunately, due to the recent shift towards virtual schooling, university students are greatly disadvantaged. With that being said, these students would become more well-rounded if an effective solution to hybrid pair programming were integrated into the curriculum once again.
To existing solutions to our problem of remote pair programming, there are a few solution-adjacent examples, yet none that fully hit pay dirt. The idea of pair programming is nothing new. Throughout the development of the computer age, companies have introduced multiple applications to help programmers collaborate. GitHub, for instance, is a household name among programmers. However, GitHub was not designed to solve the specific issue of pair programming. Rather, it is a project management internet host designed to help store software development. There is no live component, at least as of yet. Another application, Zoom, allows for 2 or more users to take turns controlling one user's desktop. However, while this feature is enabled, the application tends to have horrendous lag and network issues, leading to confusion and frustration by all parties involved. Additionally, time is wasted during brief pauses in service and server-wide outages, affecting millions of users like the one reported by Zoom on a status page during the week of Monday, August 24, 2020. The closest solution our group discovered was Visual Studio's Live Share extension. This extension allows multiple users the ability to use the same Visual Studio IDE simultaneously. It even comes with a built-in voice chat feature. Unfortunately, the Visual Studio's Live Share extension is not ideal as it has several shortcomings, which makes it difficult to use in our problem's context. For instance, users must be familiar with the Visual Studio interface, and the user with the project files must be online for others to have editing privileges. So, though it remedies one problem, it goes on to create multiple others.
Adhering to guidelines and principles is one of the most important things to pay attention to when creating software. It ensures that software is created with its users' best interests in mind. The existing solutions that we have described adhere to several guidelines that we discussed in class, including the Practice Universal Design and Create Accessible Documents guidelines. GitHub adheres to the Practice Universal Design guideline as it is usable for all its users, although it requires time to learn how to do the advanced stuff. Zoom also has accessible features as it allows users to turn their cameras and microphones on and off. Additionally, Zoom allows its users to share screens, which is a good feature for pair programming. These existing solutions that we described also adhere to some design principles such as permit easy reversal of action and offer informative feedback to ensure that the best product is put forth. For example, it will automatically scan for errors when uploading a file. Additionally, GitHub will tell its users where those errors occurred in. However, the learning curve to master error detection in GitHub is a bit steep. These guidelines and principles are important to our group when coming up with our solution.
In hybrid synchronous courses, current methods of pair programming have their own issues, including, but not limited to, lack of intuitive use, asynchronous collaboration, one-user sessions, and lack of easy file sharing. To solve these issues, our software would afford coding, so that users can edit open files in a text field that takes up the main application window, communication, a voice chat and text chat will allow users to talk with one another while working, which is a vital facet of pair programming, and file sharing. Files will be stored on the cloud and available for download at any time, so that users may have an up-to-date version of the file available to them. All of these affordances will be accompanied by easy-to-understand signifiers, such as buttons, labels, or graphics. An easy-to-navigate user interface allows users to intuitively know how to use the software. Users should also have an easy time setting up the software and understand how their pair programming session went afterwards. All of that should help lessen the gulfs of execution and evaluation for users. Our ultimate goal is to improve the pair programming experience for students in hybrid synchronous classes. To see if we've met our goal, we'll measure success by providing testers with a multi-question survey, which will gauge whether they liked our solution software more than traditional software. The answers to each question will be scored, and that will provide direct feedback about user satisfaction with our solution software on a case-to-case basis. Answer choices will correspond to a score between -2 and 2, with scores below 0 representing negative responses, and scores above 0 indicating positive responses. This approach allows us to decide if our goals have been met, while also taking into consideration user feedback on which parts of our software are good and which parts need improvements.